do not even like to figure out formulas, even when I tell them formulas are easy to figure out. All right. So what I want to do is, sorry, just give me 1 second. Yes, here we go. All right. So with this, all right. So the percent of change. Now again, do you know what the formula is for that? I'll be impressed. What? No, you don't. All right. Sit down. Sit down. Sit down. Let me get started. All right. What is it? What? No. Okay, listen. I really want to just, I want you to find a place for this. And again, this is how I remember, or I knew that it would be difficult for me to remember this formula. But if you were able to think about it logically, it's really simple. All right. So let's say, for example, you were making $100 an hour. Come on now, here's where you have to listen. All right, I mean it. You got to be focused here for a second. And then if you remember this little situation, then the whole thing will be easy. All right. Let's say you were making $100 an hour and your boss came to you and said, wow, you're doing so great. I'm going to give you a 10% raise. All right. So how much would you be making? How much? You would be making $110. All right. So again, I am pretty confident that everybody in here knew that. Come on, Alden, sit down. Nope, sit down. No, I don't care. Sit down. Just listen for a second. All right, it's too late. I'm already in the middle. All right. So now, everybody agree that is a 10. Come on, put the calculator down. All right. All I want you to do is listen. All right. If you can remember this formula, this whole front and back should take literally. It really should take about 15 minutes. All right. If you understand the formula. All right. So I'm asking you, if we started making $100 an hour and your boss gave you a 10% raise, and now you're making $110, I'm asking you now, just giving this information, what percent raise did I just make? What percent raise did I make? You made a 10%. How do we know that? Because I told you it was a 10% raise. Now, let's say I didn't tell you. Let's say I didn't tell you. William, you're not listening. I can tell. You're writing. Stop. Put your eyes up on the board. All right? You'll never have to remember this formula. And you'll get a problem right that most people don't know how to do if you just listen for a minute. Let's say you didn't know that was a 10% raise. You're looking at the numbers 100 and the number 110. How does that convert to a 10% raise? How does that convert to a 10% raise? Jacob. 110 minus 100. You're so close. So close. Tell us, how do I make the numbers 100 and 110 make 10%? That's what I'm asking you. How do you do that? No, wrong. You're not listening. What do I do? You only can use the numbers 100 and 110. That's what I'm trying to get you to understand. Tremble, what? Not sure? Tell me what I do. No. So if I said this, let's say, for example, 50 to 73.22. What's the percent increase? We don't know. We don't know what it is. I'm asking you, how do you find that? How do I do that? You're close. You're almost there. I'm pretty happy with you on that. Tell us. No. So now I'm going to ask Oscar right up here, but I want to only look at the numbers 100 and 110. What do I do? How do I make that 10%?
100x.
No, you're supposed to look at that. What do I do? What does 10% mean? Let's start with that. 10 out of what? 10 out of 100. So now, this is silly, but now I'm going to write what 10% is. 10 out of 100. How do I get that using 100 and 110? What do? Subtract them. So if I do 110 minus 100, what do I get? Now, how did I get 100 on the bottom? That's where it started. So listen, the formula for percent of increase or decrease is always what you said, the change. In order to find the percent of increase, you always have to find the change. How do you find the change? You do what? Subtract the two numbers. You always subtract the two numbers. So again, I'm trying to show you 110 minus 100 is 10. Then what do I divide it by? The first number or the second number? Well, let's look. There's two numbers, 100 and 110. What am I dividing by? Man, I just can't even believe my ears. Guys, stop just saying things. I'm not sure what you're doing. Look up. It's not funny to me, Oscar. Come on. What does 10 represent? Someone tell me what 10 represents. What does that represent? Stop. You're not listening. What does that represent? No. What does it represent? I said a specific word. What does that represent? No. What did I say it represented?
The race.
So the change. For those of you guys who are listening, the numerator represents the change. So I went from 100 to 110. How did that change? By 10. It changed by 10. How do I find the change? I already said that too. How do I find the change? I'm looking at Wow. You can look at the two numbers. How do I get 10 with 100 and 110? I'm asking you, with these two numbers, 100 and 110, how do I get 10? Subtracting. Now, what did I subtract? This is the first or the second number? What's this number then? The first. This is the what? Because it comes what? After the first. After the first comes the
Second.
Wow.
How do you?
You know why I have no hair. Come on. This is the first. This is the second.
Oh.
What are we talking about? Now, again, William, how do I find the change? You subtract them. So I went from 100 to 110, so I got 10. So after you subtract them, you divide by what? 100. 100 is the first number. But instead of saying the first, we always say it's the difference divided by the original amount. It's the difference divided by the original amount. So that, in fact, is the formula for the percent of increase or decrease. I think I just wasted time. So I'm going to say it one more time. Put your hand down. Most people cannot remember that formula for some reason. If I said the percent of increase or the percent of decrease, to me it's just the change divided by the original amount. But most people can't do that. So what did I try to show you? I tried to show you that it was easy to calculate that. Well, not so easy for us, but at least hopefully now you understand. If I know 100 to 110 is 10%, I now can say, wow, to get 10%, I just subtracted and divided by the original amount. That's what I was trying to say. That's the formula. I have a feeling my introduction was not so great, so everybody should write on their paper the percent of increase or decrease is always the change divided by the original amount. The change divided by the original amount. Did you write that down? Thank you for that. Okay, so now, all right, we're ready. No kidding. Thank you. Okay, so now, everybody, I want to know. Now, listen, this is embarrassing. From 12 to 18, is it increase or decrease?
Increase.
Okay, so do I really care if you put increase or decrease down? No, because if you don't know if it's an increase or decrease, there's no point in doing the worksheet. Right? Come on now. You have to look at that and say, wow, is it going up or is it going down? And for some of you, yes, we know 1 first, 2 second.
I think that's a D.
All right. So, for number 1, thank you. It's increased by what percentage?
50%.
No, because it goes up 6 and then you divide it by 12.
It's 50%. 33.
Stop. I feel like this is a comedy show here, guys. Stop and stop. Just
0.5. It's a 50% increase. It's not.
stop. No, I don't even care if you set it up. I would like everybody in here to be like Alden and say it's obviously 50% without doing any work. Right? Because we went from 12 to 18, which is what?
6.
Divided by 12. 6 out of 12. 0.5. That's the decimal. So we're going to change it to 50%.
Turn it to a decimal.
I'm smart. I got 2.
6 divided by 12, not 12 divided by 6.
Wait, okay, so then I have
6 divided by 12. Now, I also want to say, guys, both worksheets are getting done, so we can now tighten up a little bit, and let me make sure that you're good. All right? Now, again, it's the change divided by the original amount. So, again, it's strictly calculator. I mean it now, guys. All right? You're going to have a lot of work to do. All right? So now, 6 divided by 12, not 12 divided by 6. All right? And that came out to be 0.5, which is the same as 50%. All right, so now let's see if I'm in good shape. So, for number 2, the change was what? Say it again. What? No. Okay, I'm not arguing with you, but I'm saying, what is the change? 3 over what? Yes, so everybody should be able to do 3 over 27 and 0.1 repeated. Now, because we're brilliant, we can say 11 and 1/9%. Now, if you put 11.1%, are you okay?
Yes.
Yes, I'm just saying I would like you to be smarter when you see repeated numbers. It's over 9, 1 over 9. If it's 2, 3 repeated, you can say 23 over 99 or whatever. If you just want to round to the nearest tenth, I'm fine with that. Put your hand down. Listen, put your hand down. I want to know, is anybody having any trouble with telling me that it's 11 or 11.1%? What? Do that on your calculator. And what does it come up with? That's right. So what is that as a percentage? You move the decimal 2 place over, like we've been doing for a week. Do you agree with me? That means you're what? What does that mean? You're not correct. That's the answer. Right. What is on your calculator, William? So what percent is that? Move the decimal to the right 2 places. 11.1. Am I right? William, 0.1 repeating is 0.111111111. If I move the decimal over once, twice, it becomes 11.111111. What percent is that? 11.1%. If you want to write it as 11 1/9, I'm okay with that, I said. Hey. All right, let's see if we can, from 4850, now is this an increase or decrease? Okay, so what is the change, someone? What was the, I want to know specifically what the change was.
It'll be $9.30.
$9.30 divided by what?
48.50.
48.50. And what does that come out to be, please?
20%.
Exactly. No, I'm not. I don't have the calculator in front of me, so I'm asking you. Was it a rounded problem or was it exactly? So we're rounding to the nearest tenth.
Oh, okay. So then 19.2.
19.2%. Right now, I just think that's simple, guys. Do we agree? Change divided by the original. Change divided by the original. Jacob, you all right back there? What?
So are we doing like if you get pretty close to
No, you're rounding to the nearest tenth. Not pretty close. This is not an estimate. We're rounding to the nearest tenth. Don't tell me it's 20%. All right, I'm not interested in 20%. What?
For that one, I got 9.7.
You got what?
I got 9.7.
What was the change?
I did 13.
Yeah, Rivers, I think you got this wrong. What is that? 9.7, not 9.3.
It's 19.75.
So listen, it's not Jacob, thank you. It's 9 what? 9.7
9.7 divided by
48.50, and that's exactly 20%. All right. All right. Now, all right, let's do one more real quick. Number 4. All right, and then we're going to go on. Yes, what did you get? What's the change?
Oh, I was
What's the change?
13.
13
So
divided by,
25.
which is?
Is,
Now, when,
52%.
52%. I'm totally happy with that.
If I'm correct.
52%. But I need some help double checking.
Yeah.
Okay. All right. Now, what I want to do is we're going down to a little bit further down the page. And now there's this thing called the percent of error. It's basically the same thing. All right. When you're studying in science, sometimes you do testing. All right. You know what the answer is, and this is what your outcome was. All right. So the percent of error is, again, the change, not by what you got, but by the actual. So listen to what I'm saying. For this, find the percent of error. It is the change, not divided by the original, but divided by the what? Actual. Divided by the actual. All right? We don't care anything about the estimate. It's the change divided by the actual. So now I want everybody to number 11. And I want somebody to round it to the nearest tenth, please. Jacob, since you got the last one, I'm going to help you. Tell me. What was the change here, buddy?
7.
No, I want the change. You're probably right, but just tell me what the change is, just to make sure. 3 divided by what?
38.
Thank you, sir.
7.9.
He says about 7.9%. Now I need some confirmation on that. Is that right? What? Shh. I'm listening to Weber now. Go.
Thank you for that. All right. Weber, I mean that too. All right. All right. Does everybody agree that's kind of easy, right? You're using a calculator, change divided by the original amount. Now I want the front and I want the back, and I want it rounded to the nearest what? 10. Rounded to the nearest 10. And I want it done before you leave. So when you leave, you just hand me your worksheet. Too late.
How would you convert this into? I'm just like giving. Like, how would you convert this?
Not an answer.
No, I know, but